Welcome to Never Rewrite. I'm Isaac Askew.
And I'm Jeffrey Sherman. And today we are joined by guest Brian Genisio to talk about a rewrite that he successfully executed at Khan Academy. Brian, welcome to the show and thank you for coming on.
Thanks for having me.
So, the genesis for this talk, you gave a lightning round speech at the latest lead dev, which was awesome. And you talked about how Khan Academy, you migrated their systems from Python to Go. It took 3.5 years, but it was successful. And I was like, oh, we have to talk about this because this is awesome on all of our levels. So why don't you, for the audience, lay out how that, just the general idea, the genesis of the project and all of that.
Yeah, so this didn't come out of nowhere, of course. There were a lot of motivations for doing this, including a really strong forcing function, which was we were on Python 2.7, and that was end of life, and Python 3.0 was not backwards compatible. So we knew no matter what, we needed to rewrite our backend one way or another.
Mm-hmm. Mm-hmm. So let me just so I've written exactly one utility in Python, and the developer that I was pairing with gave me a compliment. She said, "Your Python is correct, but it looks like a Java developer wrote it." And I'm like, "Well, totally, you've got me." So it was idiomatically wrong, but it worked correctly. How breaking was the change from Python 2.7 to 3? Because I know it wasn't forwards compatible, but just how bad was it?
I don't know. To be honest, I was not in that initial decision to do this, and so I tend to be a front end developer who's full stack, and at the time I was an IC. I'm a manager today, so when we made this decision, I really didn't get involved with the difficulty on why we were going to 3.0. I just know that this was the forcing function for us. We're on a Google Cloud platform, and they were going to support us for a little while after end of life, but they also wanted us to get off of it, and so we knew we had to move to something. But yeah, I don't have an answer for that. I don't know off the top of my head. I'm sorry.
Oh, that's cool. So right off the bat, you've hit one of the fundamentals that Isaac and I have sort of hit on in the past about that makes a rewrite successful, which is you had a forcing function that forced you to do it. You had to get off Python 2.7. Google was not going to let you stay. Mm-hmm. And so it wasn't optional, which was one of the things. Like you had to do it. You had to do a rewrite, and you had to finish it at some point. So that is immediate. So it took 3.5 years, if I remember right, if I wrote it down right.
Yeah.
So that was brutal. Could you tell us more about that process?
Sure. So, I was a part of this process at the very beginning, and that was grinding through everything that Khan Academy is and does. And we took a few different perspectives, one of them being product focused. So, not what is the code that we have, but what are the things that we do? And we even broke that down into two main categories. One we called minimal viable experience. We didn't call it product because we already had a product. What are the things we do today that make us us? And if we stopped doing them, we wouldn't be Khan Academy anymore. That was minimal viable experience. And then there was everything else. The other things that may or may not directly support that. We are not a user management platform, but we have user management, and that is necessary for that MVE. So that makes it into the MVE. But you might look at something like reward mechanics and say, well, if we didn't have reward mechanics, we're still Khan Academy. Our mission is still there. And so that would not make it into the MVE. And so that was the product perspective. And so the entire product team grinded through every single thing we did and categorized things by team and function and things like that. And then we also looked at it from a technical perspective. And, we had already started this process of thinking about starting to split in Python our monolith into services. And so we already had boundaries within the code. And so we kind of looked within, even though it was a monolith, we looked within these boundaries to start asking ourselves, what are the things that this system does? Another thing we were doing was migrating from REST to GraphQL when we had to make this decision. We were about halfway through that process as well. And what we really realized, this totally makes sense when I started to think about it, is 98% of all code gets executed in the back end via some API
Mm-hmm.
entry point, whether it be REST or GraphQL or whatever. And so then we started thinking about it from that perspective. Not the code, that's overwhelming. There's a million lines of code there. But here's every single REST endpoint, GraphQL query and mutation that we currently have. Now that doesn't cover everything, but that gets us started. And then we start looking at it. What features do these things support? What is the current traffic? What is the complexity? Tons of spreadsheets. Every team had them, and we really just grinded through every single one of these to figure out, this is in REST, so it needs to move to GraphQL. That's part of this work. This is in GraphQL. It can be ported the way it is. And this is really complicated, and there have been dragons here in the past. This is going to be at a higher estimate for moving it. So we really thought about it as endpoints and entry points to GraphQL from a technical perspective.
That's awesome. So how long did it take the minimum viable experience? Did that get finished earlier than the 3.5 years, or was that?
Yeah. The minimal viable experience was a little less than 2.5 years. And then we worked on the remaining parts of it the following year plus. And after the minimal viable experience was done, we were able to start freeing up engineers to start working on new features, because we had a rule: no new features in Python. Because of course, if you were to put a new feature in Python, you also then have to port that feature to go.
We talked about this last episode too, actually.
Yeah. Okay. Yeah.
So
You don't want to.
I got a question for you. Then,
Yeah.
so for these boundaries, for the minimum viable experience boundaries,
Mm-hmm.
for the things that fell outside of those boundaries, was it just that after you ported the ones that were within the boundaries over, the ones outside the boundaries were just disabled until they were ported as well?
No, they were still in Python. So, we very much adopted a strangler fig pattern here. And GraphQL made that, basically enabled that for us, because we weren't porting at the feature level, we weren't porting at the object level, we were porting at the field level.
Right.
It was entirely possible to have user.first name be in Python and user.last name be in Go. And so we just moved things over. And so by the time the MVE was over, all of the things that supported the needs of those features were in Go, and all the things that were in what we called endgame, the second phase of this, were still in Python. And then they needed to move over as well.
So that is a huge thing that you just pointed out that I want to emphasize and I guess bring up and tease out more. So you had incremental, like you were delivering. You didn't have a 2.5 years where you built the new thing in Go and then flipped the switch and turned it on. You were incrementally, as Isaac and I have come up with the term Theseus shipping, from Theseus, the ship of Theseus, where you've incrementally changed everything in it, but it was always the same Khan Academy.
Yeah. We use the analogy probably very similar of saying that we were rebuilding our airplane while we were flying it, bolt by bolt. We would get shipments brought to the airplane, we would replace it, and then we would drop the old stuff. And by the end, we still had a flying airplane. It was just it was, instead of B-52 bomber, it was a stealth bomber, whatever. So, that's the analogy we used a lot to try to explain to people what we were doing, but it sounds like it's probably very similar to what you're calling Theseus.
Yeah. So could you go in, because the way you described how you were using GraphQL as a strangler fig, it was interesting, and I hadn't heard people doing it that way. So could you tell the audience more about that?
Yeah, absolutely. So, in the strangler fig pattern, you have to put a proxy in front that then routes essentially to one or the other version of the thing that you're trying to replace. And that proxy was our GraphQL gateway. We started out with the Apollo gateway, but ultimately ended up writing our own gateway because we were able to do it much faster. Still, though, that's the idea, is that when you make a query to the federated gateway in GraphQL, there's a query planner that figures out which services to send it to, because each service ends up having their own GraphQL schema. It stitches it all together, and then the client doesn't know, but it may be making a request to the user service and the progress service and the content service all in one query. The way that GraphQL works with its nodes and everything. So you automatically get this proxy that is the gateway that sits in front of everything. And what we realized is that we could make a couple directives. These were just custom built directives within GraphQL that allowed the same fields and mutations to exist in more than one service. Because normally you wouldn't be able to do that. You couldn't have username.firstname in the username service and then username.firstname in the admin service, right? Because the schema, the federator wouldn't know what to go to. So we built a system that added directives to these fields that would say, this is currently the one to route to, essentially, and this is the one not to route to. And that's the overall outside view of it. And then what that enabled us to do is side-by-side testing. So every single field we could move from being routed to Python to actually going to both places. And the Python one is what comes back, but then you've got data to compare, and then we build a report for it. And as soon as that's clean, then you switch over. The Python one exists, but the Go version is now the one that's in prod. And then once you're happy with that, you can just delete the Python one, remove the directive from Go, and then now everything's completely in Go and doesn't even exist in Python. And we had something like, I think it was 5,400 fields and mutations in our GraphQL API. This was literally done one by one.
Oh, wow.
Yeah, sometimes we'd group them, right? First name and last name have a lot of synergy, and so we would group them together. But our reports were individual fields, and then we could look at it and say, hey, there's some problems with last name, but first name's good to go. All right, let's move first name over. As an example, it's usually a little bit more complicated than that, but that's the basic idea on how we were able to use GraphQL as our strangler fig pattern.
That seems really, really powerful. Like the ability to support both, the new and the old, and then also get a report on the differences between them. Have you considered, and I don't know where Khan Academy stands on this, but considered open sourcing that piece of it? Be like, hey, here's a strangler fig enabler for GraphQL that helps you cut over. That seems like it would be a very useful piece of software for the world.
It was so bespoke that it would be hard to extract, I think. It wasn't hard to implement, though. It's the type of thing where, if you spend a little bit of time, because the Apollo Gateway, for example, is open source. And I should add that I'm pretty sure, don't quote me on this, but I'm pretty sure the Go implementation of our GraphQL Federation server is open source. And so that would be built in to our Federation server. And we're actually still using a portion of Apollo. We're using the query planner portion, because that's one of the hardest things, figuring out how to route all these things. We use a query planner portion from in Node. It's a separate service. And because this is an internal API, it's highly cacheable. So we just kind of say, here's the query, it gives us the plan, we hold on to the plan until we have a new version of the schema, and then we bust the cache and use it again. So it's not like one of those things where you could just grab the server out of open source and just use it. You'll have to set it up along with a query planner. But I'm pretty sure it is an open source project at this point. We built a couple of different open source GraphQL tooling. I just don't remember which. It's a 100-person organization, so it wasn't my part of the organization.
Right. Whenever you started, How long did you think it would take to port everything over?
We originally thought it was going to take about 2.5 years,
Hmm.
um, but and it took 3.5 years total. Um, but that was based on heuristics.
Hmm.
It's very difficult to estimate how long a project like this is going to take until you
Right.
start. And so we used a heuristical model for estimating. It was more like waterfall, less agile. And I could go into why we went this way. I can justify this, but um,
No,
uh,
we found that more waterfall, the more you can define what it is you have, the easier the rewrite kind of project goes. That's another thing that you guys
right.
did correct. Like that, we found really helps with this kind of operation is if you know defining what you have up front.
Yeah, because it's immutable,
Mm-hmm.
right? Agile's great when you're when your priorities are shifting and you're trying to
Right.
build something from scratch. But when you have a thing that you know it has to do all the things and it can't do anything that's not in there, or else you break the site. Um, Agile doesn't give as many benefits in that case. And so we really, going back to what we did, is we use a heuristic to say, I think it was somewhere around 50 lines of code per person per day. And that's how we started. And we created spreadsheets and tools to go figure out, what these things are, and then we could look at it and say, this is how much it's going to take. But anytime you hear a number like 50, you know that it's not accurate because that's clearly a human convenient number to pick. It's not real.
I
Um,
can write 50 lines of comments. Boom, like that.
yeah, right, right.
I'll
The
have ChatGPT do
reality
it.
The reality, after we spent some time working on this, when we actually looked at our burn downs and whatnot, is that if we were to then take that heuristic and apply it to the reality, it was probably more like 40 lines per person per day. All of a sudden, we got something that our burn down matched our plan, and that's kind of what got us to a longer tail. And then there were other things unforeseen that you just can't, when the project's this big, you just can't estimate. We knew there would be unforeseen things, but we didn't know, for example, that we were going to have to replace the GraphQL gateway because Node.js was just too slow in processing data. When you
Hmm.
put every request through this one bottleneck, that thing has to be fast, and it turns out it wasn't fast enough for us, and so we had to build our own gateway. We didn't do it because it was fun; we did it because we had to. Um, and with that, you can't plan for that. You can only plan for something like that will happen, right?
Right, the unknown unknowns
Exactly,
in a
exactly.
plan.
And so we had padding for that, but we probably didn't have quite enough. So there were some things that had to come up and made the schedule. And if you look at our burn down chart, you'll see these bumps in it, and they usually represent things like that, where we realized the strategy we went with, the actual technical strategy wasn't exactly what we were going to end with.
Yeah, I remember from the slides in your presentation, you said you started with 1 million lines, approximately 1 million lines of Python. You want to tell the audience how many lines of Go you ended up with?
A little bit more than a million lines ago. Yeah. And they're not, it's not perfect. It's not a perfect comparison, right? Because after 2.5 years, we started building new features in the new system. We also deleted features that we decided we weren't going to port. But even then, deleting features requires an estimation and an effort. You can't just turn the back end off because the front ends
Right.
start to fail. So you have to synchronize that. There's messaging campaigns when things go away. You have to go find if there's users that are heavily using it and make sure that they hear the message, they see the
Right.
message. You give them time to get off of their dependency on it, things like that. So, but so some things didn't get ported, new things got added. But in the end, I think the statistic I have was, yeah, I mean, I've got exact lines here, but it was approximately 1 million lines of Python and 1.1 lines of Go when the project finished.
So I think an interesting driving factor here that makes it a little bit different from the other rewrite stories that we've talked about before is that you had to do it. Right. This was a
Mhm,
forced
mhm,
upgrade. And some of the other ones we've discussed on the show before were like we were considering doing it because of scaling issues. It wasn't a forced thing. It was like it would be more
mhm,
efficient if we built it this way, or it's solving like a bottleneck if we built it this way. Um, And then we had talked about too, Jeffrey, like some of them will start and then you'll burn through so much cash with pulling your developers off other features to try to do this rewrite that eventually management might get frustrated and say, all right, screw this, we're going to kill the project because we need you guys working on the other things that are making money. Whereas
Hmm.
again, here, this had to happen. You had
Hmm.
to upgrade this version.
Right.
So that's kind of a great driving factor that provides a bit more oomph behind the message, so to speak. Whereas the other ones, you had the option to quit.
Yeah, and it would be disingenuous for me to suggest that it had to be done this way,
Okay.
because we didn't just we could have just gone to Python 3. We could have stayed in this halfway point between Rust and GraphQL. We could have stayed monolith. Um, but these were all things we were currently working on migrating towards, and what we
Mm-hmm.
didn't want to do is port the system that way. And then there were other things like, we as an organization just found Python wasn't right for us. Over time, Python wasn't the right language for us. We thrive in a statically typed language, and um, also, people will argue with this. I've seen plenty of people arguing this point, but
Spaces,
goes
tabs.
but oh yeah, Go is faster. Go is just faster for us than Python. Maybe you can optimize the Python to be as fast as Go, but in general, we found the same code ran an order of magnitude faster in Go than it did in
Mm.
Python. And when you have
Hmm.
millions and millions of requests every day, the user doesn't notice the difference that it just ran, that the actual code executed 10 times faster. But our bottom line notices
Oh,
that
for
it
sure.
executed. When you talk about fractional percentages of computing power, and the number of instances that need to be running and things like that, we notice a significant drop in our overall operating costs to run our
Hmm.
instances. Um,
Did you
and
expect that,
yeah,
or that was
yeah,
just a
we were
happy?
really hoping for that. Yeah, we were really hoping for that, and all estimations we did up front when we chose Go, because there were other options that we could have picked, including Python 3. But when we chose Go, we one of the things is we said, in for the examples that we had ported, as our just tracers, we found that they executed on the server approximately 10 times faster. Um, and there's all sorts of reasons for that, and again, I've been trolled on the internet, or we've been trolled on the internet for suggesting that, and it's not an argument I want to have. When we looked at our implementations, that's what we got.
Right. It doesn't
And
matter what you can do; it matters what we can do.
that's right, exactly. And and in the end, also static typing was important because Kotlin was another choice for us. For example, we chose to not use Kotlin. There were others in the list.
Nice.
Oh, yeah.
So one thing Isaac hit on, and I know was part of your presentation that we
Mhm.
didn't touch on at all. So the pressure to have new features and that impacting the bottom line. So you had a 2.5 year major freeze followed by a
Mhm.
year of minor freeze. How
Mhm.
did that impact your product organization and maybe the company's bottom line, if that's something you can share?
Sure. Well, bottom lines are different for us because we're nonprofit.
Hmm.
Um, we're in a for-profit world. Every user makes you money, ideally.
Mm-hmm.
In a nonprofit world, every user costs us money. And so we just think about finances differently than you
Hmm.
would if you
Right.
were a for-profit company,
Interesting.
where it's more about opportunity costs when we don't write new features than it is sales. I mean, that's not. It's more complicated than that because we do have some sales channels, even though we are nonprofit. We do have some offerings, but um, I think bottom line is one we were less concerned with. We were more concerned with a few things. Number one is, as a product organization, when you talk about product managers and designers, it's really hard being in an organization, having all these ideas and being told no
Mm-hmm.
for years at a time. And that was extremely difficult for our organization. Enough that if you look at who was in the design and product team when we started and who was in the product and design team when we ended, I think the answer is one person stayed from the beginning to the
Oh,
end.
wow.
And
It's
that,
huge.
yeah, that's huge. That's absolutely huge. And again, it would be a disingenuous and oversimplification to say it's only because of this, but it was a big driving factor. And then from a product perspective, even though we're nonprofit, we do have quote unquote um, uh, um, we have people that are our competitors, and they were building features ahead of us. We don't necessarily need to worry as much about competitors in this space, but we do need to care about relevancy.
Right.
I talk a lot about the Mr. Wizard factor. Um, you may be old enough to remember Mr. Wizard.
I remember Mr. Wizard.
Yeah, but yeah, so there's probably an age difference there between the two of you. You both know Bill Nye the Science Guy, though, right?
Mm-hmm.
I
Right.
do. Yeah.
So Mr. Wizard was a precursor to Bill Nye the Science Guy. Bill Nye the Science Guy just did it better and more flashy and had better marketing. And
Hmm.
Mr. Wizard, who in my childhood experience was pretty awesome, lost relevancy and no longer. Most people don't even know who that person is anymore. And
I I just
and
assumed
we
he
risked the
had
same
died
problem.
because
Oh
I
my gosh.
I
well,
don't
no,
think
he
so.
was in my mind he was an older man on TV in the mid
Yeah,
'80s. So
yeah.
it's 30 years later. He's probably not with us anymore, and
I
that's why you don't hear
you
from
know
him.
I got it. Yeah.
I don't
I
know
will
the
Google this
actual
after the
story.
show.
Yeah, yeah. I don't know the actual story. I just use it as an analogy of
Yeah.
nobody knows Mr. Wizard unless you were a kid
Got it.
in the '80s. But everybody knows Bill Nye, and there wasn't a lot of time in between. I think, I want to make sure that we remain relevant, that we can
Hmm.
we can fill out our mission. And when you don't develop features for 2.5 years, a lot of things happen. Our SEO dropped significantly because we weren't paying attention to
Right.
it. Other companies were building out SEO features that increased their SEO juice. And we were not. So we got outsearched, and there's a lot of things that happened in that space where we simply um, you know fell behind in the market. And thankfully,
Yeah.
this was a success. It didn't kill us. We walked away and immediately built a very prominent feature on our system that we call Conmigo. It's an AI-driven tutor.
Hmm.
It's getting a
Oh,
lot
cool.
of attention, and our new system allowed us to build it very quickly. So thankfully, we were able to recover from this. But
Hmm.
during that time, it was a pretty big hit to the organization.
Yeah, and I can imagine too. Like if you said that there was so much churn in the product team because of,
Mhm.
presumably just because of the lack of being able to be effective product people. They're trying to pitch these new ideas, and none of them can happen because of the freeze. I can see that frustration. So there's so many different pressures here that this rewrite was able to withstand to deliver that seems a bit uncommon compared to other rewrites we've talked about.
Mhm.
Yeah, I don't think the pressures were uncommon, but your ability to actually deliver in the face of those pressures is extremely uncommon.
Yeah.
Yeah, because what's also happening during this time is the pandemic, and we tripled our traffic overnight during that time, and that caused its own struggles and difficulty in sometimes deprecating things. We had to think about strategy and things like that. And we're in the middle of a rewrite when that's happening.
Hmm.
So there's that happening as well. It did change the way that we think about. The entire industry thinks about toolings like Khan Academy, when all of a sudden we really need some offline asynchronous learning tools
Hmm.
uh, that we didn't need as much before for different forcing functions.
So I had one more topic. If you have a little bit more time, uh,
Sure.
you mentioned at the end. So the one of the big pitches that people always say is, "Oh, we're going to do this rewrite, and then everything we're going to be able to do such good development. It's going to be so fast." And
Hmm.
then usually that never happens. But it sounds like so you did the rewrite, and um, was the code that you started with okay? You said it wasn't performant enough, but like
Hmm.
was the Python? good code, or was it like, oh man, this terrible code base that we had? And are you guys happy with the Go code and the way it's formatted now? Is it doing all the things that you wanted and hoped?
Yeah, I think so. So, on the scale of horrible to excellent, I would say we had bad Python and we now have good Go. So, in some ways we ported some things pretty much verbatim over to Go, and so therefore we have some of the smaller architectural pieces are still the same in Go. Um, that being said, one of the things that slowed us down was lack of tests from two perspectives. One of them is our testing wasn't great, but the other is that testing wasn't great on a dynamic language, and your
Mm.
compiler is your first line of unit tests in when you lack unit tests, right? And so going to a static language, and then also in the process, we wrote a ton more tests. It's easier to move fast in a world
Mm-hmm.
where you have much better test coverage than
100%.
and then you also have all of the contracts that static types give you come along with that too, and so because of that, yes, we are developing new features significantly faster than we ever did before. It's hard to measure
Right.
efficiency, but um, but we were able to put out this and bring to market this AI tutor product the day that OpenAI released uh, ChatGPT 4 because it was built on ChatGPT 4. We were partnering with them under the hood.
Hmm.
We were doing this while we were finishing the port. Um,
Wow.
in the very end, and we were able to get it done. We did that a month and a half after we finished the port. We put out this um,
Wow.
the first version of this new feature. So
Is the migration done? Like the Python is off, it's not running in production? Totally
hmm
gone?
yeah, totally
Nice.
gone. It was done. It was done on January 27th. We were able to turn it all off.
Excellent. So if I could summarize all of the amazing things you and your team did, seemed like you did correctly, or as we would define it correctly here at Never Rewrite. Uh, you used the strangler fig pattern to do side by side comparison and testing. You did incremental delivery, where you never had a giant work in progress and an untested set of code. You were doing feature by feature, and when you were happy, you cut it over. And so there was not a lot of untested. There was never any real untested, unworked code. You were able to, or you did a huge amount of upfront work defining what the current system was before you started to move it over. And you were able to freeze out any changes so that you didn't have to, you didn't have new work coming in that you had to then port over as well.
hmm hmm Yeah,
Awesome.
that's correct. Am I proving your thesis?
Well, our thesis is that rewrites generally don't work, and you should do all of those things that you did instead.
Okay. Yeah,
And
so instead
so,
of
yes,
rewrite, you should rewrite.
yes. Well, that was the
We've come
feedback
to
we
this
got from the
conclusion a few
internet
times.
on the first show. So, yes, instead of rewrite, you should rewrite.
Okay.
That's why we came up with terms like thesis shipping, where
Right, right.
I
we're
love
trying
it.
to use the ship of Theseus metaphor to say, look, it's the
Well,
exact same
yeah,
thing.
the idea too is that the overwhelming pressure that you face to rewrite, you have to basically have a cosmic alignment of forcing factors, being able to
hmm
resist product pressures, and all of these things that you've just described to actually deliver, such that we say never rewrite as a catch all for pretty
hmm
much you should never rewrite unless you have this perfect alignment. And it
Sure.
just seems like you've had that. Yeah.
Yeah, and I would be a fool to claim that this was repeatable, right?
Right.
It worked.
Thank you for saying that. We needed that.
Yes.
Yeah, no, it worked, and we have a lot of lessons learned, and I'm telling you my
hmm
lessons learned, the things that went well, the things that didn't go well, etc.
hmm
But it worked for us at the time that we did it with the people we had and the technology that existed. Um, this could have killed us.
Hmm.
It was an existential risk for us to do nothing,
hmm
and it was an existential risk to do something. And so we chose the least risky existential risk.
Got it.
to go with. So yeah.
Yeah, that's a big point out. You basically you're betting the company on this rewrite.
Right, but doing nothing, we were guaranteeing that
Right.
the
Google would
Possible
eventually
failure
shut you
versus
down.
certain failure.
Google would have shut us down. Yeah, in fact, they would have probably shut us down a lot earlier than when we ended. They held on with us because they knew we were actively working on it and showing progress and whatnot. But we
Mhm.
did have a contract with them that said we would finish by January 31st of 2023. Um,
And
Oh,
you
so you
finished
finished
what,
with
4
4
days
days to
early?
spare.
yeah,
Wow.
that's right.
Incredible.
Awesome. Brian, this has been awesome and an incredible episode. Thank you so much for coming on. If people want to learn more about you or get in touch or learn more about Khan Academy, how would they do that?
Sure. Well, I'm Brian Genisio on LinkedIn. As far as I know, I'm the only one. And yeah, I work for Khan Academy. We are our mission is to provide a free world-class education for anyone, anywhere. And we are always hiring, or I should say, we are often hiring. You can go to our careers page and see what roles we're hiring for today. Um, and if you're not familiar with Khan Academy, I think it's pretty amazing. So check it out. You can learn anything that's on our platform at least.
Awesome. Thank you so much, Brian. Uh, and thank you for listening. I'm Jeffrey Sherman.
I'm Isaac Askew, and this is Never Rewrite.